Okay, let's walk through this server code together. It's a basic example of how to implement the Model Context Protocol, which we often call MCP. MCP is all about using WebSockets for connections and communicating with JSON Remote Procedure Call version 2.0 messages. Think of it as a structured way for different parts of a system to talk to each other. First off, we're setting up an HTTP listener. This listener is like a doorman, waiting for connections on localhost at port 5000. It's specifically looking for WebSocket connections at the path /MCP/. The idea here is that MCP connections usually start with a regular HTTP request, and then they get upgraded to a WebSocket connection for more efficient communication. Alright, now we actually start the HTTP listener. This tells the doorman to open the door and start listening for anyone knocking. So the server is now actively listening for incoming connections. We'll print a message to the console just to let us know that the server is listening. Next, we're going to accept one of those incoming HTTP connections and turn it into a WebSocket connection. To keep things simple, this server is designed to handle only one client connection at a time. It's like a small coffee shop that only has one table. We need to make sure that the incoming request is actually asking to become a WebSocket connection. If it's not, maybe it's just someone trying to access a regular web page. We'll reject it. We're only interested in WebSocket connections here. We'll print a message to the console if we receive a non-WebSocket request. If it is a WebSocket request, great. We'll accept the WebSocket handshake. In this example, we're not specifying a sub-protocol, which is like agreeing on a specific dialect of the WebSocket language. We're just using the basic WebSocket protocol. Now we have a WebSocket object, and that represents our connection with the client. We'll print a message to the console just to let us know that a client has successfully connected. It's always good to have some feedback. We need a place to store the data we receive from the WebSocket, so we create a buffer. Think of it as a temporary holding space for the incoming message. The next thing we do is jump into a loop. This loop is the heart of the server. It's where we'll be handling all the incoming JSON Remote Procedure Call messages from the client. The server will keep listening for messages as long as the WebSocket connection is open. It's like waiting for orders at our coffee shop. Inside the loop, we're going to receive a full message. This message could be a JSON Remote Procedure Call request, like asking the server to do something, or it could be a notification, which is just the client telling the server something without expecting a response. WebSocket messages can sometimes be split into multiple pieces, so we need to loop until we've received the entire message, indicated by the end of message flag. We receive data asynchronously from the WebSocket and put it into our buffer. Asynchronous means that we can do other things while we're waiting for the data to arrive. We check to see if the message type is close. If it is, that means the client has decided to close the connection. In that case, We need to acknowledge the closure and then exit the loop. It's like saying goodbye to a customer who's leaving the coffee shop. We'll print a message to the console when the client closes the connection. If it's not a close message, we'll append the received chunk of data, which is a text frame, to our message builder. The message builder is like a container that we use to piece together the complete message from all the chunks. We keep looping, receiving chunks and appending them to the message builder until we've received the entire JSON message. The end of message flag tells us when we're done. Once we have the complete message, we convert it from a series of bytes into a string. Now we can actually read and understand the message. We print the received JSON to the console. This is really helpful for debugging and seeing what the client is sending us. Now comes the fun part. We need to figure out what the client is asking us to do. So we parse the JSON remote procedure call message. Remember, MCP messages are JSON remote procedure call version 2.0 objects, and they have certain properties like JSON RPC, method, parameters, and sometimes an identifier. We try to get the method property from the JSON. The method tells us what action the client wants us to perform. If we find a method property, we extract its value as a string. Now we know what the client is asking us to do. We need to figure out if the client is expecting a response from us. If the message has an identifier, it means the client is waiting for a response, either a result or an error. If it doesn't have an identifier, it's just a notification, and we don't need to send anything back. We try to get the identifier property from the JSON. The identifier is like a tracking number that helps the client match our response to their original request. If we find an identifier, we store its value. The identifier can be a number or a string, so we need to be able to handle both types. We create a variable to store the JSON response that we're going to send back to the client. Now we start checking the method to see what the client wants us to do. If the method is initialize and the message has an identifier, it means this is the first step of the MCP handshake. The client is sending the initialize request to set up the connection. In this case, the server needs to respond with its protocol version, its capabilities, which include things like resources and tools that it supports, and some information about the server itself. We then construct the JSON remote procedure call success response object. This object includes the JSON RPC version, the identifier from the original request, and the initialization result that we just created. We serialize the response object into a JSON string. This turns our object into a format that we can send over the WebSocket. Since this is just a notification, we don't need to send a response. We'll just print a message to the console to let us know that the client has finished initializing. We create a variable to store the content of the resource that the client is asking for. We try to get the parameters property from the JSON, and then the name property from the parameters. The name property tells us which resource the client wants. In this simple example, we only have content for one resource, welcome.txt. A real server would probably look up the resource in a database or generate it dynamically. We build the JSON remote procedure call success response with the resource content. If we couldn't find the resource, we'll just send back null. We serialize the response object into a JSON string. We create variables to store the two numbers that the client wants us to add together. We try to get the parameters property from the JSON. We extract the values of A and B as integers. We build the JSON remote procedure call success response with the sum result. We serialize the response object into a JSON string. We construct the JSON remote procedure call error response object, including the JSON RPC version, the identifier from the original request, and the error object that we just created. We serialize the response object into a JSON string. Now, we're ready to send the response back to the client if we have one. The response needs to be sent as a text WebSocket frame. We send the response asynchronously to the WebSocket. We print the sent JSON to the console. If the loop ever exits, for example, if the client closes the connection, we need to stop the HTTP listener. This frees up the port so that other applications can use it.